Alright, we're going to make the motor specification calculator program. And so what we want to do normally is we want to stake out some area for a user interface section. So I'm going to highlight a nice big box that's going to be my user interface. Might put a big border around it or something. Come in here and we'll merge these cells. And I'll put in a title here, so motor specification calculator program, whatever you can call it, whatever you want. Center, and let's see, where's the other center? There it is. Okay. And let's make this. Whoops, I spelled some stuff wrong here. Specification calculator program. All right. Okay. Something like that. All right, so what we want to do is we want to have some places in here in the middle where users are going to be able to enter in some information about a particular motor. So we want them to be able to put in voltage. We want them to be able to put in the no load current. We want them to be able to put in the no load angular velocity or speed, we'll call it. We want them to put in the stall current and the stall torque. We want them to be able to put all those things in. Let's see here. I might want to move that over a little bit. And you want to space these out probably a little bit. I'm going to do this really fast, so you'll want to make yours look a lot better than mine. So anyway, here is, in these cells is where they can put the information. So I'm going to highlight those cells. This is going to be an important step. We're going to go up to Format, Cells, and we're going to click on Protection, and then we're going to click Unlock those. So what that means is that eventually these cells here will be the only places where a user could enter information. They won't be able to change anything else on the entire program. They'll be able to enter information on here, and then they'll eventually see how it changes on graphs that'll be over here and over here, something like that. Let's put labels on here. This is going to be in volts. This is going to be in amps. This will be in radians per second. Let's see, what do we got? Current is amps, and torque is actually Newton meters. Okay, and I could highlight all the rest of this and let's see, make it be something weird. And I'll put those in. Let's just go ahead and make those white, I guess, and let's do little borders right there, so we can see that the places that you can put in some values. Okay, and like I said, you should work on making this really look really neat. Okay, so we're going to come down here somewhere, and this is where the guts are. Though we're going to have all our kind of our programming and things and stuff down here. So I'm going to have a lot of columns. I'm going to have torque. I'm going to have speed. I'm going to have power output. I'm going to have volts or voltage. I'm going to have current. I'm going to have power input. and I'll have an efficiency. Okay, so what's going to happen is, let's say someone enters some values. I'm going to go ahead and enter some values in here that the user will say will put in, so I have something to work with. So let's say the voltage is 3 volts, like it was in our lab. The no load current, we'll say there was 1 amp when there was no load on the wheel. The no load speed, we'll say, was around 3 radians per second. The current stalled, and there was 4 amps, we'll say, and the stall torque, we'll just say, was 2 Newton meters. So I'll put in some values in there. Okay, so what we want to do is we want to we're going to have 2 graphs that are based with torque on the x-axis, and we want to see, at what torque is this particular motor, the most efficient, and at what torque does it have its maximum output power. So, and we want both of those on there. And we're also going to have another graph that shows you the current at various torques and shows you the rotational velocity, the speed at various torques also. So what we're going to do is, to be able to make data points to be able to graph, we're going to make like 100 data points. So we're going to come down here and we're going to start with a torque with no load. So if no load, we know that there was 0 torque. So then, what was our maximum torque? Well, our stall torque was 2. So we're going to go from 0 up to 2, and we're going to divide that by 100 pieces, and then add that on as we go down. So we'll have 100 data points here. So this one is we're going to have this cell here be equal to that cell plus, and then we're going to get our stall torque right there, and we're going to divide that by 100. Now on this one, I'm going to drag this cell down, and it's going to copy this formula all the way down, but I actually want it to always go get this stall torque every single time, so I need to put some dollar signs in there for the stall torque, so that when so $G $10, so that when I copy this formula down, it doesn't copy G10 or increment G10. It goes and gets G10 every single time. That'll be important. But it will increment all the rest of these here. So I can return on that, and then I can take this and I can drag it down. Let's see, whatever, starting at 26. So I basically want to go down to like about 126 or so. And so I should end with 2. So this is torques all the way from no load torque all the way down to my stall torque, which is at 2. Okay, so now what do I have for speeds? Okay, so at the beginning here we have our speed with no load is 3. So we could do equals this right here. That'd be G8. I'll just do equals, I'll do $ G8. And that's our initial speed. And then, of course, what's our stall torque? What's the speed going to be when I have stall torque? Of course, it'll be 0. So what I'm going to do this time is I'm going to equal this particular cell. And every time I'm going to subtract off the stall torque, which are the no load speed, which was G8, minus, or G8 divided by 100. I'm going to divide this no load speed by 100 also, have those little increments, and I'm going to subtract it off every single time. Now I'm going to need dollar signs again on this. Okay, and now if I get that one, I could drag that all the way down. And so it should go to my no load speed all the way down to my torque, stall torque speed, which of course would be 0. And it's close. That's like almost 0. Okay, and I'm going to go ahead and put 0 in for that because it should be 0 at the end. That will help out. It's close enough. Okay, power output. Well, power, of course, is torque times speed. So wherever I have at the beginning, I'm not going to have any power because I have 0 torque. And at the end, I'm not going to have any power because I have zero speed. So I can just do equals this cell times this cell, return. And I can take that, I can copy that all the way down. Like so. Okay, voltage is pretty easy. It's going to be equals that cell right there, equals G6. And I can do dollar signs and dollar signs. And that voltage is always going to stay the same, so I can actually copy that all the way down. That'll be an easy thing. No real formula there. All the way down, like so. Okay. Okay, let's see, then, let's see, I'd like to, okay, so now, let's see, I want to, okay, so the current no load current, of course, is equal to this right here. It's G7. Like so. Whoops. Didn't want that. Okay, and what we're going to have to do here is we're going to our starting current, our no load current was 1 amp, and then our stall current was 4 amps. So we have a difference of 3, so 1 up to 4, and so we're going to divide that difference by 100 and add that on every single time. So I'm going to do equals. I'm going to take this cell, and then I'm going to plus, and then I'm going to I'll do parentheses. I think that should work. And I'm going to take the stall current minus the no load current, close parentheses. I'm going to divide that by 100. And I'm going to have to put dollar signs on these because I want that to go get those every single time. Like so. And so that added that on. So I'm going to take that formula, I'm going to drag that all the way down, and hopefully, if we do it right, it'll be all the way up to our stall current, which is 4. And there we go. Okay, so I got my current increments all the way up also. Okay, what is power input? Power input is V times I, right? Voltage times current. So I'm going to take equals this times this. I get that. There's my power input. And I can drag that all the way down. There we go. There's our power input. And then efficiency, of course, is equal to power output divided by power input. And we're going to take that whole thing times 100 to get my efficiency. Like so. So our efficiency is 0 at the bottom and 0 at the top, at the stall current, and also at the no load current. Okay, so now I have all those, and so now what I can do is I can make some graphs that I want to make. So I'm gonna the most important graph will be how does the power output change depending on the torque, and then how does the efficiency change on the torque, because the efficiency of a motor is not necessarily at the same torque that the maximum power output of the motor is. So I want to see two graphs there so we could actually figure out how much torque do we want to be, what torque do we need to have our maximum efficiency, and what torque do we need to have our maximum power output. So I'm going to go ahead and highlight the torque column first. That's going to be my X. It's always good to highlight the X first here. And I need to find a faster way to do that. And then the power output. So I'm going to have to hold down the command key to highlight another column. There we go. And I'm going to come up here and I'm going to insert a chart, and I'm going to do a scatter chart is what we want, and we'll do smooth line scatter, and there it is. And let's do some things on here. Let's go ahead and delete that. And let's see, under chart layout, I think is where I want to go. Chart title, title above the chart. I'm going to do, let's see, this was power, max power, and efficiency versus torque. I'm going to have both of these graphs be on the same graph. Okay, axis titles, vertical axis title, rotated title. Yeah, let's do that. And let's call that one, this was power. Whoops. Power output. And that's in watts. Okay. All right, let's put this graph over here. Yeah, maybe let's put it on this other side. I got more room over here, I think. There we go. Okay. All right. We also, on the same table, we want to put efficiency versus the torque. So I'm going to click on this, and I'm going to go up to, let's see, chart source data. and that was series 1, and we'll call series 1, we'll name series 1. Series 1 was power output, and that's good. Category x-axis labels, let's see. Okay, good. All right, so let's add a new series. Whoops, I didn't name that, did it? Power output. Click OK, I suppose. Whoops. Okay, come back up here. Chart, source data. There, power output. Okay, series 2, we're going to call efficiency. I'm going to get my x values, which is going to be, of course, my torque again. So I can highlight those. And I click this back down, and then I can get my y values. I click on this little grid thing, and my y values are going to be this time my efficiency. So I'll highlight these cells. That's good. And that's okay. All right. Let's see. So, okay, so now we have this second axis, our second series put on here, but what we want to do is we want to put the axis on the correct thing. So I have power output over here, which was this one, and so this one is efficiency, and what I want to do is I want to control click on that and go to format data series, and I'm going to make this the secondary axis, so it'll put that over there. Now let's see, let's click, let's see, how do I want to do this? Primary axis. Let's do it different. Let's go. Format data series. That was the primary axis. Let's do this one, format data series. Okay, let's keep that the primary axis. Let's see if we can do it this way. Control, format data series, let's make this the secondary axis. There, that'll look better. Okay. All right. So that's good. So we need to go. So this this over here, 0 up to 25, is my efficiency. So I need to come over here and change this. This is going to be efficiency. Efficiency. And this over here, I need to add another title here. Let's see. Chart axis titles, secondary vertical axis title, and I want rotated will be max power in watts. There we go. That'll work. Okay, so here's my torques down here, and you'll notice that at a higher torque, I have, in fact, if I come up here, I can figure out my max power. Here's another thing we should do. Let's click on this. How about if I double click on it? How about if I control click on it? Format text. Okay, formatted text, and let's see, efficiency, and that's going to be on this one. That's the red. So we're going to do font color red on that side. Good. Okay. Control click on that one. Format text. And on this side we want blue. Max power. Okay, so now we'll have it more color coded. So you can see that at a higher torque, I'm going to get my maximum power, and technically that would be at half of the stall torque, of course, half of the stall torque. And then a little lower torque, I'm actually going to get my highest efficiency. Okay, so I got a table there, or a graph there. Okay, and as I change things on here, up here in the user entry, then things will change on the graph, and that's going to be a problem. It doesn't go any higher than that. Okay, so now I want to make another graph, so I'm going to do torque. I'm going to highlight my torque. And current, we're going to do torque and speed. Let's do that first. Okay, we got torque and speed. Insert a chart. We're going to do a smooth line scatter. We'll delete that. Chart layout, chart title, title above chart. This is going to be speed and current versus torque. And let's see, just do a axis title, vertical axis title, rotated title. That first one I did was speed, radians per second. And if we, let's see, format the text, we're going to have that be blue. And then we're also going to go, let's see, let's move this up here. Click on it, go to chart, source data. Series 1 was speed. And now we're going to add another one, and this one's going to be called current. X values are, of course, going to be these. X value is going to be our torque. Y values is going to be our current. right. Click OK on that. And then, so this is our current. I'm going to control click on that and format the data series. Make that a secondary axis. Okay. And then I can chart layout, axis title, secondary axis, vertical axis title, rotated, and I'll call that current amps. Control click on that, format the text. Make that be red. Okay, there we go. So now I got two graphs that will change when someone puts different specs in here, and we'll be able to see at different torques what the current would be or what the rotational speed would be at different torques, where is our maximum power, where is our maximum efficiency, and so on. Okay, I think what I probably want to do here also is, because when I did, let's see, if I put in 6 there, then it went up off the chart. So what I think I need to do is I need to click on this, and well, I took maximum off. Let's just take that off. I guess I'm going to have to put something on there. Maximum, I'll check mark that. See if that helps. Yeah, okay. So I guess I needed to leave that checked. Yeah, I'm going to leave all those things checked. Okay, so now when I change anything here in the user box, these things will all change. And you make this look neater and nicer and things like this. So what I want to do now is to clean up my program, make it look cool. So I'm going to insert, I'm going to come down here and click in this thing, and I'm going to insert a text box. Text box somewhere. Where is it? There it is, text box. And I'm going to come down here, I'm going to put a text box over all of this stuff so I can cover it up. So no one's going to actually see all the gobbledygook and stuff behind the program. Okay, and I'm going to have to actually click on this border. If I can, let's see. I'm going to go up to format. Let's see, layout. Nope. Yeah, format. Line. Oh, come on. Format. Line. No line. So now there won't be any line there. So that's going to be good. So what I'm going to do, if I go to layout, I can click on the headings and the grid lines. And that took off all the headings. It took off all the grid lines. And I got something weird here. I don't know how that box got there. I got a border or something around it. I'm going to take the border off. Okay, I got to put a bottom border back on. There we go. It's not good enough. There's a thicker bottom border. That's the one I want. Okay, there we go. All right, so I got weird things. I got it cleaned up though. Okay, another thing I can come down to is I can come down here to a cell that's down here somewhere beyond the corner. Come out here a little ways. I can go to Window. I can freeze panes. And so now when I do that, now if I try to scroll down or over, I can't actually scroll away from this. The program's right there on top. It's really nice. So then what I'm going to do is I'm going to go up to Data, Protection. Nope, Tools, sorry. Tools, Protection, Protect Sheet, not Workbook, the sheet, protect the sheet. and then I can click. I want the user to be able to select unlocked cells. I do not want them to be able to highlight or select any locked cells. So I'm going to unclick that box. I'm going to keep that one clicked. Then I can come in and put some kind of a password in here. And put it in twice, and I click OK. And so now this thing is password protected. So a user can click on any of these things, nothing, they can't change anything, they can't move anything around. The only place they can click in are these boxes right here. And they can add different things in. They can add 6 radians per second, and then it's going to change all of the graphs. And I could say, okay, how does this all look at 9 volts instead of 3? Okay. What if the torque is like 8 instead of 2? And it's going to change all the graphs each time based on the motor specifications. One thing I think I just forgot is I should have put somewhere down here like Herman Programming or something. So do a little programming name, and you need to try to come up with your own nice looking motor specification calculator program.